So in this video, we're going to find an explicit solution of the given initial value problem dy over dx is equal to y squared minus 1 all over x squared minus 1 given the initial condition y of 7 is equal to 7. So the first thing we're going to do here is to separate the variables. That means that all of the expressions containing y will move that here in the left-hand side of the equation, and all of the expressions containing x must be in the right-hand side of the equation. So dx will move that here to the right. So how do we do that? We will multiply this whole equation by dx over y squared minus 1. So as you can notice here, we have y squared minus 1 in numerator, so we'll put y squared minus 1 in the denominator of our multiplicative inverse, and we have dx in the denominator, so we'll put dx in numerator, okay? So after that, we multiply dx over y squared minus 1 times dy over dx. We just cancel dx, so we'd be left with dy over y squared minus 1 is equal to, we multiply dx over y squared minus 1 here, so we cancel y squared minus 1. So we'd be left with dx over x squared minus 1. So we successfully separated the variables, all of y here, all of x here. So the next thing we're going to do is factor these denominators. So as you can notice, these are difference of two squares. So the formula for difference of two squares is a squared minus b squared is equal to a minus b times a plus b. So you can treat this expression here as y squared minus 1 squared, x squared minus 1 squared. So you can easily factor these out. Okay, let's go factor these. Y squared minus 1, we can factor that into y minus 1 times y plus 1. So same thing with the x squared minus 1, we can factor that here, x minus 1 times x plus 1. Okay, now we have the factored form in our denominator. So the next thing we're going to do is to decompose this partial fraction. Okay, the reason why we're decomposing this into partial fraction is that so that we can integrate it easily. So this is how you decompose into partial fractions. So you'd put two individual fractions and you put one factor here, y minus 1, and the other factor here, y plus 1. Okay? And you put a plus sign here. And you just assume any variables a and b here. And then multiply both sides of the equation by, we multiply that by this one here. If we see the denominator is y minus 1 times y plus 1, so we multiply both sides of the equation just to cancel this one here. Okay, so whatever is written here, we'll multiply, we'll use that as our multiplier. Okay, so we have here expression, this expression 1 over y minus 1 times y plus 1 multiplied here, so that this will cancel out, right? And this too. So we now have 1 here in the left hand side of the equation, and we multiply this to here, a over y minus 1 times y minus 1. I'll just write this here so that you won't be confused. Y minus 1 times y plus 1. So cancel y minus 1, you'd be left with y plus 1. So let's just write y plus 1 here. This is a times y plus 1. plus, if we multiply b over y plus 1 times y minus 1 times y plus 1, we can cancel y plus 1 here because y plus 1 over y plus 1 is just 1, right? So we can actually write the expression b times y minus 1. So we'll delete that. B times y minus 1. So we now have this. So we just set values of y to make it easy. So if y is equal to 1, obviously this expression here would be 0 because 1 minus 1 is equal to 0, right? So that's the reason why we set y is equal to 1. So that will make an equation which is like this. Y is 1 plus 1 plus b, y, 1 minus 1 is 0, so we just make it 0. So we now have 1 is equal to a times 2. So multiply that with 1/2. We now have a is equal to 1 times 1/2, it's 1/2. 2 times 1/2, cancel. So that's why we have a here. Okay, so same thing with b. So if we set y is equal to negative 1, this expression here will become 0. So again, we set y is equal to negative 1 just for this expression to be 0, so that we'll have b left in our right-hand side of the equation. So we can find the value of b easily. So 1 is equal to a times 0 plus b. Y is negative 1 minus 1. So we now have 1 is equal to b times negative 2. So we multiply negative 1/2 here. Both sides of the equation, 1 times negative 1/2 is negative 1/2. Negative 2 over negative 2. Or negative 2 times negative 1/2 is 1. So we'd be left with b. So we now have values of a and b, which we will use here. We'll plug that in here. See? So let's go delete this. Let's go delete. Pardon me. Okay. So we now have our decomposed partial fractions. You remember we have dy over, let me write it down right here, is equal to dx over x minus 1 times x plus 1. So this here is now 1 minus 1. Okay, so this here is this here, right? A over y minus 1, and our a is, remember, 1/2. So we have 1/2 over y minus 1. And our b is what? B is negative 1/2. So we'll put that one here all over y plus 1. So we have this dy. So as you can notice, we don't really have to decompose this because they're the same partial fractions. We just change the variable y to x, okay? So if you decompose this, we'll have the same decomposition, but you just change y into x. So we'll have 1/2 all over, change this, x minus 1 plus negative 1/2 all over, change this y to x, so x plus 1. So that's just it. Now we can easily integrate both sides of the equation. But before we do that, let me delete this first. Okay. Now Let me delete this first. So now we have these two right here, right? We can actually cancel these things out here. 1/2 out, 1/2, 1 over y minus 1 plus 1, 1 over y plus 1. So we just factored out the 1/2, and this, no, this one now here is negative. See, moving this out and factoring this out, the whole expression 1/2 would be left with 1 over y minus 1 minus 1 over y plus 1 dy. Same thing with here. 1/2 1 over x minus 1 minus 1 over x plus 1 dx. Okay, so we can now integrate both sides of the equations, and we will have 1/2 integral of 1 over y minus 1 minus 1 over y plus 1 dy is equal to 1/2 integral of 1 over x minus 1 minus 1 over x plus 1 dx. So, since we know that the integral of 1 over y minus 1 is just ln of y minus 1, take the absolute value, right? Minus the integral of this here is ln y plus 1. Okay, we have this in our left hand side of the equation. So same thing with our right hand side. We also have ln x minus 1 minus ln of x plus 1. We now put a constant c here, okay? So, according to logarithm, there is this rule that says ln of a minus ln of b is just ln of a over b. So we can use this one here and make this like this form. 1/2 ln of our a is y minus 1, our b is y plus 1. So that's it, is equal to, same thing here, we do it like that. Our a is x minus 1 and our b is x plus 1. So we still put the c here, and we want to multiply this both sides of the equation by 2. So we'd be left with ln of y minus 1 all over y plus 1 is equal to 2 times 1/2 is 1. So we'd have ln of x minus 1 all over x plus 1 plus 2c. Okay? So let's go here. So next thing we're going to do is to raise both sides of the equation. So the next thing we're going to do is to use e. If we make these an exponent, our left-hand side is ln of y minus 1 all over y plus 1. We can actually do that, but we have to make sure that we also put e here and make this our exponent also. ln of x minus 1 all over x plus 1 plus 2c. But according to the rule of logarithm, e to the a plus b is just equal to e to the a times e to the b. Okay, so we can actually make this. Let's go delete this. You remember that one? It's just e to the ln y minus 1 all over y plus 1 is equal to e to the ln of x minus 1 all over x plus 1 times e to the 2c. Okay, so this is still a constant. We just use another constant. Okay, and according to logarithmic rule, we can simplify this one here as y minus 1 all over y plus 1. So if you don't know how to do this, I have some other videos that explains about this one. So it's just like canceling out e and ln. So we also have x minus 1 over x plus 1 here times e to the 2c. Okay, so what we want to do next is we express y in terms of x before we plug in this initial condition. So we can actually do that by multiplying this here, y minus 1. We multiply y plus 1 to both sides of the equation, and we would have y minus 1 in the left-hand side, and we have x minus 1 all over x plus 1 e to the 2c times y plus 1. Okay, so let's go delete this and to simplify these. Okay, now that we multiplied y plus 1 to both sides of the equation, we will now have y minus 1 is equal to x minus 1 all over x plus 1 times y e to the 2c plus e to the 2c x minus 1 all over x plus 1. So we can move this in the left-hand side of the equation. So it's just the same as subtracting the additive inverse or adding the additive inverse. So we now have 1 y minus x minus 1 all over x plus 1 y e to the 2c is equal to this one here moved to the right hand side of the equation. That's 1 plus e to the 2c x minus 1 all over x plus 1. Okay, so now we can actually factor out the y. We now have 1 here, because if you factor out y, obviously you get 1 here, minus what's left if you factor out y, x minus 1 over x plus 1 e to the 2c is equal to 1 plus e to the 2c x minus 1 all over x plus 1. So we divide both sides of the equation by 1 minus x minus 1 all over x plus 1 e to the 2c. We divide this one here, so that would be left with y in the left hand side of the equation. So whatever is the factor here near or beside y, that's what you divide. So if you divide the left hand side of the equation by this one, you should also divide the right hand side of the equation by this one. Same thing here, same thing here, e to the 2c. So now we can cancel this out because that says 1. So we have y is equal to 1 plus e to the 2c times x minus 1 all over x plus 1 all over 1 minus x minus 1 over x plus 1 e to the 2c. So now we have y in terms of x. So we can actually plug in the value of our initial condition, which is, so remember, y of 7 is equal to 7. This means that if your x is 7, then the value of your y is 7. So we plug that in. X is equal to 7. 1 plus e to the 2c times 7 minus 1, because x is 7, over 7 plus 1, all over this here, 1 minus, again, 7 minus 1, all over 7 plus 1, times e to the 2c. So this is actually 1 plus e to the 2c. This one is 6 over 8, all over 1 minus 6 over 8, e to the 2c. Okay, so this is, if x is 7, then y is 7 too. So we should plug that in here. 6 over 8 all over 1 minus 6 over 8 e to the 2c. So how do we know? How do we know the value of c? What's the value of c? So again, we will solve for the value of c. What if we assign c is equal to 0? We just assign it directly. 1 plus e to the 0 times 6 over 8 all over 1 minus 6 over 8 e to the 0. So that's just 1, right? So 7 is equal to 1 plus 6 over 8 all over 1 minus 6 over 8. So is it 7? We'll have to multiply 8 here, multiply 8 here, and we have to multiply 8 here. So 8 times 1 is 8, plus 8 times 6 over 8 is 6, all over 8 times 1 is 8, minus 8 times 6 over 8 is 6. So we have 8 plus 6 is 14, and 8 minus 6 is 2. So this is 7. So we notice that if x is equal to 7 and y is equal to 7, if x is equal to 7 and y is equal to 7, then c is equal to 0, right? So we now plug in that. Our explicit solution is this actually here, 1 plus e to the 2c x minus 1 over x plus 1 all over 1 minus x minus 1 over x plus 1 e to the 2c. But c, now we found the value of c, which is 0, so we can plug that in there. 1 plus, so e to the 0 is 1, so we can actually neglect that. We don't write that one. X minus 1 over x plus 1 all over 1 minus x minus 1 all over x plus 1. So we just neglect this because this is 1, this is also 1, right? Because we found that the value of c is 0. So we can actually multiply both sides, no, not both sides, I mean the numerator by 1, x plus 1, all over x plus 1. So this is just 1, right? So we can actually multiply and do this in our right hand side of the equation. X plus 1 over x plus 1 is just 1. So it's just multiplicative identity. So 1 times x plus 1 is, we write x plus 1 here, plus x minus 1 over x plus 1 times x plus 1, we can cancel it. So we'd be left with x minus 1. So same with the denominator, 1 times x plus 1, we have x plus 1 minus x minus 1 over x plus 1 times x plus 1, we can cancel this, we'd be left with x minus 1. So we would now have 1 plus 1 plus negative 1, we can cancel this because this is just 0. So we're left with x plus x is 2x all over. So this, we can remove the parenthesis by multiplying the negative times x. So that's minus x on minus negative 1. That's just plus 1. So we can actually remove this and this. So we now have minus x plus 1, right? Because remember, x plus 1 minus x minus 1 is just x plus 1 minus x plus 1, okay? So cancel. X minus x is 0. Cancel that out. 1 plus 1 is equal to 2. So we now have y is equal to x, which is the solution of our initial value problem. And we actually proved that this one is correct because we have a check mark. So that's it. Thank you for watching my video.